Welcome to part 1 on functions. We'll first look at a function concept. We'll look at words like height is a function of age. Now, off the top of your head, you might not know how to write that as a function statement, but let's think about the statement f of x. We write that as f parenthesis x close parenthesis. So if we use that same statement here, we can say is like your equals sign. And we can then just replace everything. Height is equals a function of age, f of age. And we have this statement where age is the input, height is the output. Now, in general, when you're a certain age, you don't have two different heights, in which case you have a beautiful function. Your age gives you a height. Your age gives you height. Throughout your entire life, you have only been one height at any given time, not two different heights. That is a beautiful example of a function. Cost of mailing a package, we'll write cost, is like our equal sign, a function of weight, f of weight. The number of bacteria in a culture is a function of time. So we have bacteria, and we'll just say numbers, number short for numbers, equals is a function of f of time. So time is our input, bacteria, numbers is our output. Tuition fee is a function of the number of credits. Go ahead and pause the video now and see if you can figure out the last one. Welcome back. The tuition fee is the equals a function of f of the number of credits. I hope you got that one right. Now let's look at some more examples of inputs and outputs. We have a correspondence between sets. What this means is if you have a long list of inputs, there should be a correspondence to a long list of outputs. Those outputs could be the same outputs for different inputs, but you cannot have two different outputs for the same input. We'll say that again later. So correspondence between sets will take place with a set of people. So if you have each person in a class, you have a class full of people, that should correspond to mothers who had those children. Now, there could be two people in a class with the same mother, and that's okay. But you can't necessarily have two biological mothers if you're just one specific person in the class. So you could have twins. Let's say you have twins. Those twins are still their own individual person, even though they have the same biological mother. And that's okay. The correspondence is a person in the class has a mother. But you can't have one person in the class who has two different mothers, biological mothers. That does not work. So, the point is, The first one is fine. The second one is not a function. Okay? To each item in a store corresponds its price. So usually there are not two different prices for the same item in a store. To each person in this class corresponds a grade in the course at the end of the quarter, etc., etc. As we progress through this quarter, we're going to use words called domain and range to represent an input and an output. The input is the domain, and the output is the range. And then there are some correspondences that you can look at, but the basic idea is for one input, just like the child with two parents, two biological mothers, which is not possible. You can't have some input giving two different outputs. This just doesn't work as a function. Okay? So let's go on to the next page. Before we move on to the next page, we have the formal definition of a function. A function is a rule that assigns to each element x in a set exactly one element called f of x in a set B. Now we've started using a totally new notation here. X is like your input, and y is like your output. Why are we using y? That's a good question. Well, if I know that x is whatever the number I decide, it's the free variable, it's a number I get to pick, and f of x is my output, then I can say that if I look at a graph, my inputs are along the x-axis, and if I have some curve, and I say that 1, 2, 3, 4, if 5 is my input, then this value along the curve of the graph is my output. The input is my domain, and the output is my range. So I've just given you input, x, domain, and output, y, f of x, and range as all things that you might see to represent what you get out of a function. So the symbols that represent an arbitrary number in the domain of a function f is called an independent variable. You might also see something called free variable. In the next video, we'll look at some examples.